Okay.
So hydrogen and helium is in the same group, right?
No.
Not
It's in the same one.
Period.
It's in the same period. Yes. Okay. But they are vastly different. Okay. Helium is a noble gas. Hydrogen is special kind of wonderful. Okay. All right. Let's see what's next. Okay. So our ions. Okay. Our ions are formed when your atoms gain or lose electrons. Okay. And why do we think that we are gaining or losing electrons? What are we trying to
Trying to
accomplish?
stabilize
We're trying to stabilize what?
our shell.
What's up with your outermost shell? What do you want with your outermost shell?
8 electrons.
You want 8 electrons in your outermost shell. What is that called? That's the outermost shell is your valence shell, but what is that process called?
Stabilizing.
You're trying to neutralizing. No balance. Wait, what do you mean balance?
To make sure that it's, I can't explain it, but
It's just to make sure that it doesn't. So it has it fulfills its cells.
No cells. Starts with an O.
Orbit.
No orbits. Loud and proud. The octet rule. We want to obey the octet rule. The octet rule states that you need to have 8 electrons in your outermost shell in order for you to look like a noble gas. I'm gonna give you a term. Well, transition metals don't get it. They do what they want, right? So you want to have a stable electronic configuration. We will learn about that later. Like your noble gases, okay? So some things have to happen, okay? So you have cation ions. Cation ions are positively charged. Cation ions form when you are going to give up an electron. Okay, bang. Electrons, protons. They are the same, right? So now, in order to form a cation ion, have positive charge, what do you need to do? You get rid of the electron. So now, however many electrons you've gotten rid of, that is how many excess positive charges you're going to have, right? All of your metals, your group 1, group 2 metals, and all of your transition metals, they will always be cation ions. In order for them to be stable and have electronic configuration like the noble gases, they must always give up electrons. Right? Yes. Group 1s and group 2s and your transition metals.
The transition metals follow that? Don't follow that.
Huh?
You said the transition metals too?
They will be cation ions. How they become cation ions, I'll teach you how to recognize that. Okay? Now anions. Electrons, protons. How do you become an anion? Anions are negatively charged.
Gain electrons.
You need to gain electrons. So now you will have an excess of negative charge. So however many electrons you have gained, that will be the charge on your ion. Okay? All non-metals and your halogens. These are all, excuse me, anions. Okay? Now, I have my own little way of remembering how see, how you gonna just judge me before you even begin, Sephora? I haven't even said anything and you judging me. Okay? I have my own little way of remembering
Scandus.
The
In high
what?
school, there was no skin. What you
Scandals.
talking about?
The
Unless you don't know.
scambus?
He's in the
Scammers.
scammers.
Scammers?
That's
What
the
school
name.
did you go to?
I know.
You know
I'm
the funny part?
sorry.
You said that same exact thing for a semester.
I did?
I said the same exact thing you said
Really?
for a semester. That's why I said it again.
Lord, see, I'm old now, so I can't remember everything. Okay? So, but who? Think about it. Who were
His jocks.
the jocks? Jockey football players, baseball players, basketball players, cheerleaders. Okay? These were people who everyone kind of sort of want to be like. Okay? That's what we have at the periodic table. Okay? But in order to be like these jocks, you gotta do stuff. You gotta either give up something or you gotta take on something. Alright? Now, your noble gases are the jocks. Okay? Everybody wants to be like a noble gas. Okay? But there's only certain things that we're gonna do, and there's only so far that we're gonna go. Alright? Everybody on the periodic table is flanked by two noble gases. Okay? Who exactly is the two noble gases that flanks the element in group 3, period 3? What's that element? Aluminum. Good. What are the two noble gases, one to the left, one to the right of aluminum? Which one is it?
Neon and argon.
Who?
Neon and argon.
Neon and argon. If you're going that way, you're going to come back and hit neon. If you're going this way, you're going to come back and hit argon. Right? You get that? Now, in order to figure out who exactly does aluminum want to be like, you have to think, I want to be like a noble gas, but I'm only going to move so far. Okay? Kind of lazy. I ain't got that much energy in me. The most I'm going to move is 3 steps. Okay?
Neon.
There you go. Aluminum wants to be like neon. How many steps does it take to get to neon? No.
3.
3 steps. How many steps does it take to get to argon?
5.
So anybody got time for argon? You asking for a little bit too much. Okay? So now we're going to be like neon. Which direction do we have to go in order to become like neon?
Left.
You need to go to the left. Alright? If you are going to the left, that means you are giving up electrons. How many electrons does therefore aluminum need to give up?
3.
3. So therefore, how many excess positive charges will aluminum
3.
have?
3.
Okay. So now what's the charge on aluminum?
3 plus.
Right? 3 plus 3. Same difference. Alright? Do we get that? Alright. Let's take another one. What is the 2 noble gases that flanks the element in period 3, group 6? Neon and argon. What's my element?
Sulfur.
Sulfur. Good. Who does sulfur want to be like? Argon. What is the charge on sulfur? -2. Because which direction are we moving?
Right.
To the right. To the right, you need to add electrons in order to become like your argon. Did we get that? All right. Let's see. What is the charge on the element in group 2, period 5?
Plus calcium.
No, that's not calcium.
It's SR. What's SR?
Strontium
Strontium. That one is.
plus 2. All right. What is the charge on the element in period 7, group 5?
Iodine.
Indian?
Iodine, not Indian.
It's a Plus one. No,
Negative one.
to the right? Oh, yeah, gated, so.
So what is it?
Negative one.
-1. We are moving one step over to xenon,
Okay.
right? Now, what is the charge on the element in group 4, period 4?
Plus.
Group 4,
Four.
GE, what's that?
That's germanium.
Four.
Germanium.
It's 3.
It will be positive.
-4
Plus four.
plus 4,
How do you change for plus four?
-4, yeah, it's -4.
-4?
Yeah.
Bet. How you, and justify. How you figure it's -4?
Wait, 1, 2, 3.
Okay.
Is that 5? Wait, it's GE, right?
Uh-huh.
Because it's close to go that way? It's that way? No?
Yeah,
Would you let me be great? Like, can I be great, Keith? Okay? Tell me, please.
Because this way is closer than going all the way around? No?
Okay? So we have the justification for the -4 is that krypton is closer
Mm-hmm.
than argon.
Yeah.
Okay? Who said +4? Nobody said +4?
But is something a little different with the transition? What's that one?
I can't really see.
You can't see what requirement can you see? You trying to
Those
say I'm
are
blocking
the-
you?
I don't want to go screen.
Okay? So now, first off, what did I say about my laziness? How far am I willing to go?
3, my
3 steps. So what do you think is gonna happen
Nada.
with group 4? Ain't nothing gonna happen. We are not going to form ions with group 4. Because you're gonna share them. Okay? Did we get that?
Group 4, no share.
You will seriously what?
We don't make one wire for that. I don't know.
No. Nobody in group 4 will you make ions for. They will never form an ion. Okay? Remember, the most we can go up to
3.
is 3 steps. That is it. Okay. Questions, comments, inquiries?
So how they reaction? Like how they react in the reaction?
We are going to form something called covalent bonds. In covalent bonds, we are going to share electrons. Right? Now, in turn, oh, we ain't get there yet.
No.
We ain't get there yet. Okay? Okay. Now, here we have a little chart. Okay? It's a little chart of what the charges would be. Okay? Now, given that we know how to look at the periodic table and figure out what the charge is supposed to be, we don't have to memorize what all the possible charges would be. But here's a little trick for you, okay? What do we see that's common in group 1?
All just a plus.
All of them are
Plus what?
Just one.
Plus 1. What do we think about?
Plus 2.
What do we think about? And
Nothing.
what do we think about group 5?
-3.
6.
-2. -1.
There you go. Okay? So the first 3 groups will have the charge of its group number. Alright? Group 1 has a +1 charge. Group 2 has a +2 charge.
Why is aluminum positive?
Okay, who does aluminum want to be like?
Majority.
Argon. Does it want to be like argon?
Yeah, it's +3 charge. Goes on the left.
Okay, so what are the 2 noble gases that's flanking aluminum? Aluminum. If you go to the left, what is the noble gas that you hit first?
Yeah.
Let's see.
To the left.
To the left. If you keep going to the left, if you imagine the periodic table as one long line, what is the noble gas that you're gonna hit? After you get to 11, who's after 11? Who's before 11, sorry?
Neon.
Neon, alright? If you go to the right of aluminum, what's the noble gas that you hit? What's the first noble gas that you hit? Argon, okay? So now, how many steps do you need to take to get to neon?
Oh, yeah,
3. How many steps do you need to take to get to argon? No. 5. How many steps am I willing to take to get to my noble gas? 3. So therefore, you're going to be like neon. You need 3 steps to get there. You're stepping to the left, so you'll be positive. Got it?
Hold on.
Huh?
Oh yeah, yeah. Wait.
Huh?
To get from, she was saying from helium?
No. Aluminum.
Oh. I was like, wait. Okay.
You had a question, Robert? Yes.
Hydrogen, right?
Mm-hmm.
We'd have to move A to get to neon.
What?
Hydrogen.
Why does hydrogen want to be like neon? Like you jumping ahead.
Right?
He didn't, what?
Hydrogen would take.
Remember, hydrogen is its own little entity. It does whatever it wants to do. It behaves however it wants to behave.
That's why it's in that little box up there.
So yeah, exactly. It's just its own little section. It does what it wants. It's not connected to anybody. Right? So the only what hydrogen does, hydrogen for us right now, hydrogen will give up an electron. And it's perfectly content just like that.
Oh yeah, because it don't satisfy the oxide rule.
No, it does not. Okay? Okay, so now what we just did with the steps and figuring out what our charge would be, we also need to figure out how do we represent this mathematically. Alright? So we have something called the simple ion equation. This is how we're going to mathematically express the formation of our ions. Alright? So here, what do we got? Formation of anions, okay? So, chlorine. What does chlorine have to do in order to become like its ion?
Again, the electron.
It needs to gain electrons. So in order to gain electrons, you're basically adding how many electrons? One electron. Right? You're adding electrons and then you're making an arrow. This arrow reads as to produce, and then you're going to write the ion. Well, how do you write ions?
Cl minus.
Cl minus where?
Top right.
So you have a superscript ion. Alright? Now what about oxygen? How does oxygen form its ion? What do we need to do? How do we write our simple ion equation?
O plus.
O
Plus 2E
plus 2E minus.
gives us O2 minus.
Good job. Who's the other one? Nitrogen. What nitrogen does?
Nitrogen also gas.
Nitrogen,
Gas 3 electrons.
3 electrons to produce.
And 3 minus.
Do we get that? Okay, good. Now, to make my cation ions. So now we have, to make your anions, you're adding an electron to the neutral atom. To make it,
Are we gonna lose points if
regularly. Okay? Now to make your cations, what do you need? You have your neutral atom. What do you need to do? What happens to it?
Lose the electron.
So what is going to happen to the whole thing?
Positive,
No. Think about the whole atom itself.
it's gonna be stabilized after it loses.
No. Before that. Okay? So you have your neutral atom and you're adding something to it. You're adding an electron to it. What do you need to do with your neutral atom if you need to make a cation? You need to what it?
Break it apart.
You need to break it apart. Okay? So this is the way that we're going to decompose our atom in order to make a cation. So let's have sodium. What would the simple ion equation look like for sodium?
Minus
And A minus.
No minus.
And A plus
No plus. Are you plusing?
any arrow.
Na arrow.
Na plus.
Oh, and A
Na
minus.
plus.
Plus electron.
There you go. Plus the one electron that you lost. Right? You taking the neutral atom, you breaking it, you decompose it into the two things that you have. Your ion and however many electrons you have. Tell me.
So we write it because that happens after the reaction.
Right.
That's why that is after the arrow.
Yes.
Alright.
We'll get to the different things, what each of these are called in the next chapter. Don't worry yet. Right? Yes?
Okay, so like in chlorine minus, so if we, yes, chlorine plus electron arrow to chlorine minus, so if we, on the other side, right side, if we like deduct another chlorine, another electron, so can we get back to the chlorine?
So if you add an electron here,
You can go back to the electron.
you can't, because if you add an electron here, it's going to be chlorine 2 minus.
So if we deduct one electron.
If you take this and you minus an electron from it, yes.
How would you write that one out?
So you would have Cl minus,
Minus 11.
no,
Because
decomposes to
Oh.
Cl plus 1 electron.
okay.
Because your homodynamic gives
Because you're taking it as a whole and you're breaking it into 2.
Oh, so you just reverse it.
Yeah.
Flip it. Makes
Yeah.
Okay.
I'm glad you said that because we're going to be doing a whole lot of flipping stuff later on. Okay? Now, if we had calcium, what does the simple ion equation look like for calcium?
arrow.
Arrow,
CH2 plus
Ca how much?
2 plus.
plus 2 E minus.
Good job. What about,
It's not cation.
huh?
It's anion.
Ooh? What's a cation?
Cation is positive.
Oh, you're right. My fault. That's supposed to be P, not P. Sorry, my fault.
It's arrow B3 plus. B3 plus 3 electron.
3E.
Good job. Do you get it?
Yeah.
Okay. So we have 2 types of bondings. Alright? We have molecular bonds and we have ionic bonds. In a molecular bond, you're formed when you are sharing electrons. Okay? In an ionic bond, you have the combination of 2 different charges. You have a cation coming in and you have an anion coming in. That's when you're going to have an ionic bond. You get that? No? Okay. a metal.
Loses the electrons,
Metal loses electrons and forms a
positive charge,
positive charge. What happens to a non-metal?
again the electrons,
They gain the electron and form what?
negative charge.
A negative charge, okay? So you have cation and your anion. Something happens when you have these two opposite charges, okay? What does an anion need in order to fulfill its octet rule?
Zero.
Ah!
Again, you got the
Again.
electron.
It needs to gain electrons, right? So think about this, right? What does a cation need to do in order to fulfill its octet?
Loses electrons.
To lose electrons, all right? So a cation needs to give something up. An anion needs to gain something. So what do you think is going to happen?
Bonds.
There you go. This is a symbiotic relationship. I need to give up stuff. Ooh, well, I need to gain stuff. Let's come together and make a bond. Okay? That's what happens with your ionic bonds. Your molecular bonds, you are sharing electrons. I want you to think about my molecular bonds. This is a marriage. Okay? We got a 30-year fixed rate mortgage. You ain't going nowhere. I ain't going nowhere. We are stuck in this for life. Okay? Now with ionic bonds, you have something is happening. What's it called? Something is. Are you sharing?
No.
Are you in a marriage?
Ionic bond, you said?
Something is
One is
happening
giving
with.
up, one is gaining or something.
Right. So there's a what of what?
Exchange.
No, we ain't exchanging that. I ain't giving that to nobody.
Transfer?
You have a transfer of what?
Electron.
You have a transfer of electrons from your cation to your anion. Okay? So, think about it. Is this really a bond?
Yeah.
No.
Who said yeah?
Uh,
Well, you said yeah.
That's the same.
This is not really a bond. Why is this not a bond?
Because you're not sticking together.
Because you're not really sticking together. Okay? Ionic bond is really an electrostatic interaction. That's a big word for saying opposites attract.
What is electrostatic?
Electrostatic interaction. Right? All that means is your positive charge will attract to your negative charge. Okay? You can think about it as, you got my stuff, I'm going to stay near you to make sure that my stuff is alright. Okay? We ain't going to be in this for life. If I see something better than you, I'm going to dip out. But other than that, we're going to stick here together. Okay? Don't get too close though. Okay? Molecular compounds. Molecular compounds are also called covalent compounds. You're making a covalent bond. Molecular compound will only occur between two non-metals. Okay? Two non-metals only. Ionic compounds happen between a metal and a non-metal. Anytime you see a metal in there, and you must be able to recognize the metal and the non-metal. Okay? Anytime you see a metal, you automatically know that this is an ionic compound. Okay? You end up with a transfer of electrons. Your metal needs to give up your electrons, so it's going to transfer it to your non-metal that needs to gain electrons in order to fulfill its octet. Alright? So you end up with your compound, your ionic compound sticking together. Do we get that? Do you understand? Questions, comments, inquiries? Remember, molecular compound between two non-metals. ionic compound between a metal and a non-metal, always. Okay?